I'm Chuck White, and today's microlecture is about significant figures. No, not that kind of significant figures. I'm talking about the way that a scientific measurement or a calculated value is reported in a compact way that reflects the underlying uncertainty of the number. Let's consider a simple example. Suppose we're on a field study and we measure the height of a giraffe. We might report this value as 15.8 feet because I think it's reasonable to assume that we could measure the height to a precision of better than 1 foot. However, it's unlikely that the precision could be better than 1/10 of a foot because giraffes sometimes slouch and they don't usually let you get that close anyway. So we report the value as 15.8 feet so that it reflects the underlying uncertainty of the value, at least in an approximate way. If we convert the value from feet to meters, our calculator will show an answer with lots of digits, because calculators don't know anything about uncertainty. But many of those digits are not significant, so it's up to us to round the final answer to 3 significant figures or digits. That's because the conversion to new units did not improve the underlying precision of the measurement. When we calculate a value by multiplying or dividing two numbers, the number of significant figures in the answer is limited by the number of significant figures in the least certain value. Suppose, for example, we measure the average speed of a race car by measuring the transit time between two posts about 200 meters apart. We can probably measure the distance between posts quite accurately, but in the absence of specialized equipment, the time measurement has a greater uncertainty, and therefore fewer significant figures. The final answer must be rounded to 2 significant figures in this case to reflect the uncertainty in the time measurement. So we have the speed in meters per second, and if we want to convert to miles per hour, we can just multiply by 3,600 seconds per hour and divide by 1,609 meters per mile. On our calculator, we get a long number that we round to 2 significant digits, and voila! The average speed is 170 miles per hour. But wait a minute, the way we wrote this number makes it difficult to determine whether it has 2 significant figures or 3. That's because it has a trailing 0 before the decimal point. In a case like this, it is always preferable to write the number in scientific notation. Now it's clear that it only has 2 significant figures, because the significant digits always appear in the mantissa of the number. For addition and subtraction, it's different. Suppose, for example, I weigh myself while holding my phone. The scale reads 180.2 pounds. That's 4 significant figures. Pretty good. Then I put my phone down and I weigh again, and it's at 179.8 pounds. 4 significant figures again. So I subtract the second weight from the first to try to find the weight of my phone, and the answer is 0.4 pounds. The difference between the 2 weights has only 1 significant figure. For addition and subtraction, the least significant digit of the answer is in the same decimal position as the least significant digit of the most uncertain operand. Now with a scale like this one, we could weigh the phone by itself and get an answer to 3 significant digits, whether we express that in grams or in pounds. However, this won't help me get a more precise value for my weight with the phone, because when I add the weight of the phone to my weight, I must round the answer to the least significant digit, which is in the tenths of pounds, and I get the same answer as before. Remember, for multiplication or division, the number of significant figures in the product or the quotient is equal to the lowest number of significant figures in the operands. But for addition and subtraction, the units of the operands must be the same. So the least significant digit of the sum or difference is in the same decimal place as the least significant digit of the least precise operand. Finally, here are 2 tips to help you. First, it sometimes happens that the least significant digit of a number is a 0 or might be followed by a 0. In this case, the number of significant figures is ambiguous. To be clear about the number of sig figs, you should convert the number to scientific notation. Also, avoid rounding your numbers until the very end. always carry at least 2 extra digits with each number for intermediate steps in the calculation, and round your final answer to the appropriate number of sig figs only at the end. This is to avoid unnecessary round-off errors in the calculation itself. Well, this has been fun. Remember, practice makes perfect, and you can practice your problem-solving skills for free at chemvantage.org. We'll see you again soon.